Welcome to a journey through the most spectacular sights our universe has to offer. Picture yourself floating in the depths of space, surrounded by clouds of vibrant colors. Brilliant reds, ethereal blues, and mysterious purples, all dancing together in the cosmic ballet. These aren't ordinary clouds like the ones we see in our sky. No, these are nebulae, nature's own cosmic art galleries stretching across the vastness of space. These magnificent formations are like celestial canvases, painted by the very forces that shape our universe. Each nebula tells its own story, holds its own secrets, and plays a crucial role in the cosmic dance of creation and destruction that's been ongoing for billions of years. But here's something that might blow your mind. When we look at these cosmic clouds, we're actually witnessing both the beginning and end of stellar lives, all at once. It's like watching a birth and a farewell in the same cosmic neighborhood. And if you think that's impressive, consider this. Some of these cosmic clouds are so enormously vast that they stretch across hundreds of light years. To put that in perspective, just 1 light year is about 6 trillion miles. These celestial factories are where the magic of star formation happens, where the elements that make up everything in our universe, including us, are forged and scattered across space. They're like cosmic recycling centers, where the remains of dead stars become the building blocks of new ones. Get ready to embark on an incredible journey through these stellar nurseries of the universe. We'll explore their secrets, uncover their mysteries, and witness some of the most breathtaking phenomena nature has to offer. And while you're here, witnessing these wonders, don't forget to join our community of cosmic explorers by subscribing to Exploring the Universe, where we bring the mysteries of space right to your screen. This is just the beginning of our adventure through the cosmic clouds. Together, we'll discover why these celestial formations have captured the imagination of astronomers and dreamers for centuries and continue to reveal new secrets about our universe every day. Let me tell you about one of the most fascinating phenomena in our cosmic neighborhood, nebulae. You know those stunning space photos you've seen with swirling clouds that look like they've been painted by a cosmic artist? Well, those are nebulae, and they're absolutely incredible. At their most basic, nebulae are vast clouds of gas and dust floating in the space between stars, but calling them just clouds doesn't do them justice. Imagine the most enormous cloud you've ever seen on Earth. Then multiply that size by billions. That's the scale we're talking about here. These cosmic clouds are primarily made up of the 2 most common elements in the universe, hydrogen and helium. These are the same elements that were created during the Big Bang, and they're still the building blocks of pretty much everything we see in space. But that's not all. Nebulae also contain traces of other elements like oxygen, carbon, and nitrogen, which give them their spectacular colors and make them crucial to the story of life itself. Here's where it gets really interesting. Nebulae are both cosmic cradles and cosmic graveyards. In these vast clouds, new stars are born when gravity pulls the gas and dust together, eventually becoming so dense that nuclear fusion begins. But they're also where stars go to die, spreading their enriched material back into space in spectacular explosions or gentle clouds of gas. Think of nebulae as nature's ultimate recycling centers. When stars die, they release their elements back into space, and these elements eventually become part of new stars, planets, and maybe even life itself. In fact, every atom in your body that's heavier than helium was once cooked up inside a star and spread through space by a nebula. Ancient astronomers called them fuzzy patches in the sky, not knowing what they were looking at. It wasn't until the invention of powerful telescopes that we began to understand their true nature. The word nebula itself comes from the Latin word for cloud or fog, chosen by early astronomers who could only see these objects as mysterious cloudy patches in their primitive telescopes. These cosmic clouds are so massive that some of them span hundreds of light years across. The famous Eagle Nebula, for example, is around 70 light-years wide. That's about 400 trillion miles. And within its boundaries, countless new stars are being born right now, continuing the great cosmic cycle that has been ongoing for billions of years. So next time you look up at the night sky, remember that somewhere out there, these enormous clouds are quietly going about their business, creating and recycling the building blocks of our universe, just as they have been doing since the dawn of time. Just as we have different types of clouds in Earth's sky, the cosmos presents us with an incredible variety of nebulae, each with its own unique characteristics and stories to tell. Let me guide you through this cosmic classification that has fascinated astronomers since the first telescopes pointed to the stars. First, we have diffuse nebulae, the cosmic giants of our classification. These are like vast, shapeless clouds, drifting through space with no defined boundaries. Imagine throwing paint into water and watching it spread. That's how these nebulae appear in space. They're often enormous, spanning hundreds of light years across, and they're where most of the action happens in terms of star formation. Then we have planetary nebulae, which, despite their name, have nothing to do with planets at all. This is actually a fascinating historical misunderstanding. Back in the 18th century, when William Herschel first observed these objects through his telescope, they appeared as round, planet-like disks. The name stuck, even though we now know they're actually the beautiful death shrouds of dying stars, creating some of the most spectacular shapes in the universe. Emission nebulae are nature's own neon signs. These cosmic clouds glow with their own light, lit up like giant fluorescent lamps in space. When nearby hot stars energize the gas in these nebulae, they begin to shine with distinctive colors, usually a striking red from hydrogen or beautiful greens and blues from oxygen. The famous Orion Nebula is a perfect example of this type, glowing so brightly it can sometimes be seen with the naked eye. Reflection. Nebulae are the cosmic mirrors of our universe. Unlike emission nebulae, these clouds don't produce their own light. Instead, they're like cosmic dust clouds that reflect the light from nearby stars, similar to how the moon reflects sunlight. They typically appear in beautiful shades of blue, not because the dust is blue, but because blue light scatters more easily off the tiny dust particles, the same reason our sky appears blue on Earth. Finally, we have dark nebulae, the cosmic shadows of space. These are the mysterious black patches that appear to be empty regions in the sky, but they're actually dense clouds of dust so thick that they block all light from behind them. The famous Horsehead Nebula in Orion is actually a dark nebula, silhouetted against a bright background, creating one of the most recognizable shapes in our night sky. What makes this classification even more fascinating is that a single nebula can actually be multiple types at once. Imagine a vast cosmic cloud where some parts are glowing with their own light, others are reflecting starlight, and still others are so dense they appear as dark patches. It's like nature's own cosmic light show, each type contributing to the spectacular displays we see through our telescopes. The study of these different types of nebulae has helped us understand not just how stars are born and die, but also how the elements necessary for life are spread throughout the universe. Each type tells its own part of the cosmic story, from the birth of new stars to the final chapters of stellar lives. Let's dive into one of the most fascinating types of nebulae, the diffuse nebulae. Imagine walking through a fog so vast that it stretches farther than the eye can see, with no clear beginning or end. That's what diffuse nebulae are like in space. Enormous cosmic clouds with irregular shapes and fuzzy, undefined edges that seem to melt into the darkness of space. The most famous example of these cosmic giants is the Orion Nebula, also known as Messier 42 by astronomers. It's such a spectacular sight that even ancient civilizations noticed it. The Maya had stories about this fuzzy patch in Orion's sword, and Persian astronomers wrote about it in their ancient texts. When you look at Orion's belt in the night sky, that fuzzy patch just below it is this incredible nebula sitting about 1,400 light-years away from Earth. The Orion Nebula is truly enormous. It spans roughly 24 light-years across, which means it would take light itself 24 years to travel from one end to the other. But here's something even more mind-blowing. Despite its massive size, the Orion Nebula is actually one of the smaller diffuse nebulae we've discovered. These nebulae are essentially cosmic nurseries where new stars are born. Within their vast clouds of gas and dust, gravity works its magic, pulling material together into denser and denser clumps. As these clumps grow, they become progressively hotter and more compressed, eventually reaching temperatures so high that nuclear fusion begins, and a new star is born. What's particularly fascinating about diffuse nebulae is that we can actually watch this process of star formation happening in real time. Well, sort of. Given the vast distances involved, what we're actually seeing is how things looked hundreds or thousands of years ago. When we point our telescopes at the Orion Nebula, for example, we're seeing light that left it 1,400 years ago, around the time the Roman Empire fell in the West. Inside these cosmic nurseries, stars aren't born alone. They typically form in clusters. The Orion Nebula is currently giving birth to an entire cluster of stars, with over 3,000 stars in various stages of formation. Some are just starting to gather material, while others are already shining brightly, their stellar winds helping to shape the nebula itself. The gas and dust in these nebulae aren't just creating stars, they're also forming planetary systems. Around many of these newborn stars, we can see disks of material that will eventually clump together to form planets, asteroids, and comets. In fact, our own solar system was born in a diffuse nebula, very similar to the Orion Nebula, roughly 4.5 billion years ago. These cosmic clouds are also incredibly colorful. The pinks and reds we see come from hydrogen gas, while blues and greens often come from oxygen. When we look at these colors, we're literally seeing the elements that will one day become part of new solar systems, perhaps even harboring life somewhere down the line. So next time you look up at Orion in the night sky, remember that you're watching one of nature's greatest shows, the ongoing process of stellar birth that has been continuing since the early days of our universe and will continue long after we're gone. It's a reminder of how we're all connected to these cosmic processes, as every atom in our bodies was once part of a nebula just like this. To better understand these cosmic phenomena, I recently had a fascinating conversation with Dr. Sarah Starfield, a renowned astronomer from the Mountain Peak Observatory. Her insights into diffuse nebulae offer a unique perspective that brings these celestial wonders even closer to home. You know, when people ask me to explain diffuse nebulae, I often tell them to think of them as cosmic wombs. Dr. Starfield explains, her eyes lighting up with enthusiasm. Just as life on Earth begins in a protective environment where all necessary elements come together, these vast cosmic clouds serve as nurseries where new stars are born. She goes on to share how studying these stellar nurseries has revolutionized our understanding of star formation. Every time we point our telescopes at these nebulae, we're watching different stages of stellar evolution unfold before our eyes. Some stars are just beginning to form, while others are already bursting with their first light. It's like having a time-lapse view of how stars come into being. What makes Dr. Starfield's work particularly exciting is how it connects to our own origins. When we study these nebulae, she says, we're essentially looking at a process similar to what created our own sun billions of years ago. The very iron in our blood and calcium in our bones were once part of a nebula like these. During our conversation, she shared a remarkable discovery from her recent observations. We've found that these stellar nurseries are far more dynamic than we once thought. They're not just passive clouds of gas and dust. They're active, ever-changing environments where countless cosmic dramas play out simultaneously. Her passion for these cosmic formations is contagious, and as she puts it, understanding the first stages of stellar life helps us piece together the grand puzzle of our cosmic heritage. Every discovery we make about these nebulae is another chapter in the story of how we came to be here. This perspective from someone who has spent countless nights studying these celestial objects reminds us that astronomy isn't just about distant clouds in space. It's about understanding our own cosmic roots and the amazing processes that made our existence possible. Let me tell you about one of the most misnamed objects in astronomy, planetary nebulae. The story behind this name is actually quite amusing and takes us back to the 18th century when astronomers were first exploring the night sky with primitive telescopes. William Herschel, the same astronomer who discovered Uranus, was observing the sky one night in 1785 when he spotted something peculiar, a round, greenish disk that looked remarkably like a planet. He called it a planetary nebula, and the name stuck, even though these objects have absolutely nothing to do with planets. What Herschel was actually looking at was something far more dramatic, the final farewell of a dying star. Imagine a star, similar to our sun, reaching the end of its life. In its final act, it puffs up like a cosmic balloon, and then, in an incredible display of stellar fireworks, ejects its outer layers into space. These ejected layers of gas form beautiful, often symmetrical shapes that float away from the dying star like cosmic soap bubbles. One of the most spectacular examples of this cosmic light show is the Ring Nebula, also known as Messier 57. Located in the constellation Lyra, about 2,300 light-years from Earth, it looks exactly like its name suggests, a stunning cosmic ring floating in space. Through a small telescope, it appears as a smoky donut, but powerful telescopes reveal its true glory, a complex structure of glowing gases in brilliant blues, greens, and reds. The Ring Nebula was first discovered in 1779 by Antoine Darquier de Pellepoix, who described it as a dull nebula but perfectly outlined, as large as Jupiter, and looks like a fading planet. When you look at it, you're actually watching the future of our own sun, as it will create a similar planetary nebula in about 5 billion years. What makes these objects even more fascinating is that they're relatively short-lived, at least by cosmic standards. While many astronomical objects exist for millions or billions of years, planetary nebulae last only about 20,000 years before their gases dissipate into space. This makes them like cosmic butterflies, beautiful but fleeting. The gases ejected by these dying stars aren't just creating pretty light shows. They're enriching our galaxy with heavy elements created during the star's lifetime. Carbon, nitrogen, and oxygen are scattered into space, eventually becoming part of new stars, planets, and perhaps even living things. In fact, some of the atoms in your body might once have been part of a planetary nebula. Each planetary nebula tells its own story of stellar death and cosmic recycling. They're like nature's own fireworks display, marking the end of one chapter in a star's life while setting the stage for the next generation of cosmic creation. When we observe these beautiful objects, we're witnessing both an ending and a beginning, the circle of stellar life continuing just as it has for billions of years. When we look at planetary nebulae through powerful telescopes, we're treated to an absolutely stunning cosmic art gallery. These celestial formations come in a mesmerizing variety of shapes that have captured astronomers' imaginations for centuries. Some take the form of perfect rings, like cosmic wedding bands floating in space. Others resemble delicate hourglasses, as if measuring time on a cosmic scale. Perhaps most enchanting are those that look like butterflies, their gossamer wings spread across the vastness of space. But here's something fascinating. Despite their eternal appearance, planetary nebulae are actually quite fleeting by cosmic standards. While a star like our Sun might live for billions of years, these beautiful nebulae last for mere tens of thousands of years, just a blink of an eye in astronomical terms. It's like catching a rare butterfly that only exists for a single day. We're privileged to witness these spectacular formations during their brief cosmic dance. These nebulae play a crucial role in the cosmic cycle of life. As dying stars shed their outer layers, they enrich the surrounding interstellar medium with heavy elements, things like carbon, nitrogen, and oxygen. Think of them as cosmic gardeners, spreading the essential ingredients for future stars and planets across space. In fact, many of the atoms in our own bodies were once part of ancient planetary nebulae, making us quite literally children of the stars. One of the most captivating examples is the Helix Nebula, often called the Eye of God. When you look at it, you're watching a preview of what our own Sun might create in about 5 billion years. The colors we see, the brilliant blues, greens, and reds, tell us stories about the different elements being released into space, each contributing to this grand cosmic recycling program. These ethereal structures serve as both endings and beginnings. They mark the final chapter in a star's life while simultaneously seeding the universe with the building blocks for the next generation of cosmic wonders. They remind us that even in death, stars contribute to the endless cycle of cosmic creation. Let me take you on a journey to explore one of the most spectacular light shows in our universe, Emission Nebulae. These cosmic clouds are nature's own neon signs, creating their own magnificent light display through a fascinating process that would make any physicist smile with joy. Imagine a cloud of gas that's been energized by nearby hot stars. When ultraviolet light from these stars hits the gas, something magical happens. The gas becomes ionized, meaning its atoms get so excited they start glowing on their own. It's like having millions of tiny light bulbs floating in space, each one powered by pure stellar energy. The colors we see in Emission Nebulae tell us an amazing story about their composition. When you look at these cosmic clouds, you'll notice a beautiful palette of colors. The dominant red glow comes from hydrogen, the most abundant element in the universe. This crimson light is so distinctive that astronomers often use special hydrogen alpha filters to study these nebulae in detail. The gorgeous green and blue hues we see come from oxygen atoms, creating a cosmic light show that would put any earthly fireworks display to shame. One of the most breathtaking examples of an emission nebula is the Lagoon Nebula, also known by its catalog designation Messier 8. Located about 5,000 light-years away in the constellation Sagittarius, the Lagoon Nebula spans roughly 110 light-years across. That's more than 1 quadrillion kilometers. Through a telescope, it looks like a magnificent cosmic lagoon, with swirling gases creating patterns that resemble waves and currents in a celestial ocean. And here's something truly mind-blowing. The light we're seeing from the Lagoon Nebula started its journey toward Earth around the time when human civilization was just beginning to develop writing systems. While that light was traveling through space, humans went from inventing the wheel to launching space telescopes. If these cosmic clouds have sparked your imagination and left you feeling gravitationally attracted to this content, why not show your appreciation with a nebulous like? And don't forget to subscribe to Exploring the Universe, where we'll continue our journey through the cosmic wonders that surround us. Together, we'll explore more of these celestial masterpieces that make our universe such an extraordinary place. Remember, every time you look up at these glowing clouds, you're witnessing the same processes that have been occurring for billions of years, creating the elements that would eventually become part of everything we see around us, including ourselves. Now that's what I call a meaningful connection to the cosmos. Have you ever wondered how these cosmic clouds create their own light show? Well, let me walk you through one of the most fascinating processes in our universe, the emission process in nebulae. It's like a cosmic dance of light and energy that's been performing for billions of years. Let's start with the stars, but not just any stars. We're talking about incredibly hot, young stars that act like cosmic blowtorches. These stellar powerhouses blast their surrounding gas clouds with intense ultraviolet radiation. Imagine throwing a bucket of water on a very hot surface. But instead of water, we have gas, and instead of steam, we get ionization. When this intense stellar radiation hits the gas atoms, it's so powerful that it actually knocks electrons right off their atoms. This process is called ionization, and it's the first step in our cosmic light show. But here's where it gets really interesting. These freed electrons don't stay lonely for long. They're like cosmic dancers looking for new partners, and when they find their original atoms again, something magical happens. This reunion, which scientists call recombination, results in the release of light particles called photons. It's nature's way of celebrating these atomic reunions with tiny bursts of light, billions and billions of them, creating the gorgeous glow we see in Emission Nebulae. Now, here's the really cool part that would make any detective proud. Each element in the nebula creates its own unique pattern of light, like a cosmic fingerprint. When astronomers split this light using special instruments called spectrographs, they can identify exactly which elements are present in the nebula. It's like having a cosmic recipe book. Hydrogen typically shows up as a bright red color, while oxygen might give us beautiful blues and greens. Other elements add their own special touches to this celestial light show. This process was first discovered in the 19th century, and it revolutionized our understanding of the cosmos. Before this, we had no idea what these glowing clouds were made of. The discovery that we could identify elements in space by their light patterns was like suddenly being able to read a book that had been written in an unknown language. What's truly mind-boggling is that this same process is happening right now in countless nebulae across the universe. Every time you look at a glowing nebula, you're watching atoms dance, electrons reunite with their atoms, and light burst forth in a celebration of cosmic chemistry. It's an endless cycle of separation and reunion, writing stories in light across our night sky. This incredible process not only creates beautiful celestial displays, but also helps us understand the chemical makeup of our universe. Think about it. We can tell what's in a cloud of gas trillions of miles away just by studying its light. It's like having a cosmic laboratory right in our backyard, teaching us about the building blocks of everything we see in the universe. Let me tell you about one of the most enchanting phenomena in our cosmic neighborhood: reflection nebulae. These celestial mirrors create some of the most beautiful sights in our night sky, and their story is just as fascinating as their appearance. Think of reflection nebulae as cosmic clouds of stardust acting like millions of tiny mirrors in space. Just as morning fog reflects the headlights of a car, these cosmic dust particles reflect the light from nearby stars. But unlike a regular mirror that you might have at home, these cosmic mirrors have a peculiar preference. They love to reflect blue light more than any other color. This beautiful blue hue we see isn't random. It's actually the result of something called Rayleigh scattering, the same process that makes our Earth's sky look blue. The dust particles in these nebulae are just the right size to scatter blue light more efficiently than red light. It's nature's way of painting the cosmos in beautiful azure shades. The most famous example of a reflection nebula is the one surrounding the Pleiades star cluster, also known as the Seven Sisters. This stunning cosmic formation has captured human imagination for thousands of years. Ancient civilizations around the world incorporated the Pleiades into their mythologies and calendars. The Greeks told stories of seven sisters placed among the stars by Zeus himself, while Japanese culture knows them as Subaru. Yes, that's where the car company got its logo. When you look at the Pleiades with the naked eye, you might see 6 or 7 bright stars. But through a telescope, you'll discover these stars are wrapped in delicate blue veils of reflected starlight. The nebula looks like ethereal silk draped around the stars, creating one of the most beautiful sights in our night sky. It's located about 440 light-years away from Earth, which means the light we see today started its journey during the Renaissance period. What's particularly fascinating about reflection nebulae is that they're often found around young, hot stars that haven't yet cleared away their surrounding cosmic debris. It's like catching a glimpse of a stellar nursery, where new stars are still surrounded by the remains of their birth clouds. These nebulae are literally illuminating the process of star formation before our eyes. The dust in these nebulae isn't just creating pretty lights. It's also incredibly important for the universe's chemistry. These dust grains can act as cosmic factories, where complex molecules form on their surfaces. Some scientists think similar processes might have played a role in creating the building blocks of life in our own solar system. Next time you look up at the Pleiades on a clear night, remember that you're watching starlight playing an elegant game of cosmic pinball, bouncing off countless dust particles before reaching your eyes. It's one of nature's most beautiful demonstrations of the simple physics of light reflection, played out on an impossibly grand scale across the cosmos. Let me tell you about the cosmic shadows that dance among the stars. Dark nebulae. These mysterious celestial formations might seem like empty voids in space, but they're actually some of the most important structures in our universe. They're like nature's cosmic curtains, dense clouds of gas and dust so thick they block the light from stars behind them. Imagine walking through a dense fog on a moonlit night. That's similar to what's happening in dark nebulae, but on an astronomical scale. These clouds are so packed with cosmic dust that they create what appears to be holes in the starry background of space. But don't let their darkness fool you. These nebulae are absolutely teeming with activity. The most famous of these cosmic shadows is the remarkable Horsehead Nebula, located in the constellation of Orion. Its distinctive shape, which truly resembles a chess knight, was first discovered in 1888 by Williamina Fleming, a remarkable woman who began her career as a maid at Harvard College Observatory before becoming one of the most important astronomers of her time. The nebula's silhouette stands out dramatically against the bright red glow of the background nebula, creating one of the most photographed objects in our night sky. These dark nebulae are actually cosmic cocoons where new stars and planets are born. Inside these dense clouds, gravity works its patient magic, slowly pulling material together. The dust and gas become more and more compressed, eventually forming dense cores that will become new stars. It's like watching a cosmic nursery through a dark veil. We can't see inside, but we know incredible things are happening there. What's particularly fascinating about dark nebulae is their temperature. They're incredibly cold, often just a few degrees above absolute zero. This extreme cold actually helps the star formation process, as it allows gravity to overcome the natural tendency of gas to spread out. Within these frigid shadows, molecules can form and combine in ways that wouldn't be possible in warmer regions of space. The dust in these nebulae isn't just ordinary dust, like you might find in your home. It's made up of tiny particles of carbon, silicon, and ice, some no larger than smoke particles. Yet despite their small size, when gathered in sufficient quantities, they can block nearly all light trying to pass through them. It's estimated that some dark nebulae are so dense they can block up to 99% of the light trying to pass through them. These cosmic dark spots played hide-and-seek with astronomers for centuries. Early observers thought they were actually holes in the fabric of space, areas where there were no stars. It wasn't until the 20th century that we fully understood their true nature as dense clouds of matter. Today, we know they're not cosmic empty spaces at all, but rather cosmic full spaces, regions packed with the raw materials for future solar systems. Inside these dark nebulae, complex organic molecules are forming, protected from harsh stellar radiation by the very dust that makes the nebulae dark. Some scientists believe that similar dark nebulae might have played a crucial role in creating the materials that eventually formed our own solar system, including the complex molecules that could have led to life on Earth. So next time you see an image of these cosmic shadows, remember, you're not looking at emptiness, but at cosmic cradles where new stars and planets are being born, hidden away in nature's stellar nurseries. These dark nebulae remind us that sometimes the most important things in our universe are happening in the places we can't see. Have you ever wondered how astronomers manage to capture those breathtaking images of nebulae? Let me take you on a journey through the fascinating world of cosmic observation techniques. When we look up at the night sky with our naked eyes, we can only see a tiny fraction of what's actually out there. That's where our amazing technological allies come in. Let's start with optical telescopes, our traditional windows to the cosmos. These incredible instruments capture the visible light from nebulae, showing us the beautiful colors and intricate details we've all come to love in those spectacular space photographs. The famous Hubble Space Telescope, for example, has been our faithful cosmic photographer for over 3 decades, revealing the stunning visible features of nebulae that would otherwise remain hidden from our view. But here's where it gets even more interesting. Not everything in space can be seen with visible light. Think about it like this. Imagine trying to see through a thick fog on a winter morning. That's similar to what astronomers face when looking at certain nebulae that are shrouded in cosmic dust. This is where radio telescopes come into play, and they're absolutely fascinating. These giants don't see light like our eyes do. Instead, they detect radio waves emitted by molecular clouds within nebulae. It's like having a special pair of glasses that can see through that morning fog. The very large array in New Mexico, with its 27 massive dishes spread across the desert, has been revealing the hidden secrets of molecular clouds since 1976. But wait! There's another layer to this cosmic observation game. Infrared telescopes like the James Webb Space Telescope are our ultimate dust-penetrating tools. They can peer through cosmic dust clouds as if they weren't even there. Imagine having a camera that could see through walls. That's basically what infrared telescopes do in space. They reveal the warm glow of forming stars and planetary systems that would otherwise remain hidden behind thick veils of cosmic dust. Each of these observation techniques gives us a different piece of the cosmic puzzle. When astronomers combine data from all these different telescopes, they can create a complete picture of what's happening in these stellar nurseries and cosmic graveyards. It's like having multiple storytellers, each sharing a unique perspective of the same magnificent tale. And here's a fascinating tidbit. Some nebulae that appear as single objects in visible light turn out to be complex systems of multiple structures when viewed in radio or infrared wavelengths. The Orion Nebula, for instance, reveals completely different features when observed across these different wavelengths, like a cosmic chameleon, changing its appearance depending on how you look at it. This multi-wavelength approach to studying nebulae isn't just about getting pretty pictures. It's helping us understand how stars are born, how they die, and ultimately how our own solar system came to be. It's a reminder that sometimes the most beautiful discoveries come from looking at things in different ways. Have you ever thought about how everything in our universe is connected in an endless cosmic dance? Well, let me tell you about one of the most fascinating cycles in our universe, the relationship between nebulae and stellar evolution. Imagine a cosmic recipe that's been cooking for billions of years. It all starts with vast clouds of gas and dust floating in space. These nebulae are like cosmic kitchen pantries, storing all the ingredients needed to make stars. When parts of these clouds become dense enough, gravity takes over, pulling the material together until it's hot and compressed enough to ignite nuclear fusion, and boom! A new star is born, but here's where it gets really interesting. Stars aren't just passive participants in this cosmic ballet. Throughout their lives, they're constantly interacting with their surroundings. Think of them as cosmic chefs, cooking up heavier elements in their cores. During their lifetimes, stars create elements like carbon, nitrogen, and oxygen, the very same elements that make up our bodies. As Carl Sagan once beautifully said, we are quite literally made of star stuff. When stars reach the end of their lives, they don't just quietly fade away. Oh no, they go out with quite a show. Depending on their size, they might gently puff off their outer layers, creating beautiful planetary nebulae, or they might explode in spectacular supernovae. These stellar finales are like cosmic fireworks displays that scatter enriched material back into space. This material, now filled with these newly created elements, becomes part of the interstellar medium, ready to be recycled into new stars and planets. Speaking of planets, let me share something amazing about this process. The debris disks that form around young stars made from this enriched material are where planetary systems like our own are born. We've actually witnessed this process in action. The famous Hubble Space Telescope has captured images of these protoplanetary disks, which astronomers playfully call proplyds in the Orion Nebula. Think about this for a moment. The iron in your blood and the calcium in your bones were once forged inside ancient stars that exploded billions of years ago. These elements traveled through space as part of nebulae before eventually becoming part of our solar system and, ultimately, part of you. The whole process is like a cosmic recycling program that's been running since the beginning of time. Each generation of stars adds more complex elements to the mix, gradually enriching our galaxy. The nebula we see today might become tomorrow's stars, planets, and who knows, maybe even future life forms. And here's a mind-blowing thought. When we look at nebulae through our telescopes, we're not just seeing beautiful space clouds. We're witnessing both stellar nurseries and graveyards. In some nebulae, like the famous Eagle Nebula, we can see stars being born while nearby. Dying stars are returning their material to space. It's a perfect example of the circle of stellar life. This continuous cycle of stellar birth, life, and death through nebulae isn't just a fascinating process, it's the very reason we exist. Every atom in our world has been through this cosmic cycle at least once, making us all true children of the stars. Let me tell you about some of the most spectacular cosmic wonders that have captured human imagination throughout history. These aren't just random clouds in space, each has its own incredible story to tell. Let's start with the mysterious Crab Nebula. Picture yourself as a Chinese astronomer in the year 1054. You look up at the night sky and witness something extraordinary, a star so bright it's visible during daylight for nearly 3 weeks. What these ancient astronomers witnessed was one of the most dramatic events in our cosmic neighborhood, a massive star exploding in a supernova. Today, almost 1,000 years later, we can still see the aftermath of this cosmic explosion. The Crab Nebula, expanding at an incredible speed of more than 3 million miles per hour, contains a rapidly spinning neutron star at its heart. Imagine a star the mass of our sun compressed into something the size of a city, spinning 30 times every second. The nebula got its peculiar name when Irish astronomer Lord Rosse first sketched it in 1844 and thought its tendrils resembled the legs of a crab. Now let's journey to perhaps the most iconic cosmic landscape ever photographed, the Pillars of Creation. Located in the Eagle Nebula, these towering columns of gas and dust became world famous when the Hubble Space Telescope first captured them in 1995. But the story gets even more fascinating. These pillars, standing about 4 light years tall, are literally cosmic nurseries where new stars are being born right now. The pillars might look peaceful in photos, but they're actually being eroded by the intense radiation from nearby young stars, much like how wind erodes rock formations on Earth, but on a much grander scale. Here's a mind-bending thought. The version of the pillars we see today might actually already be gone, destroyed by a supernova shockwave, but because they're 7,000 light-years away, we won't know for sure for thousands of years. Finally, let's talk about the magnificent Carina Nebula, one of the largest and brightest nebulae in our night sky. This cosmic colossus spans over 300 light-years across and is home to some of the most massive and luminous stars known in our galaxy. At its heart lies a true stellar heavyweight, Eta Carinae, a star so massive it contains more than 100 times the mass of our Sun. This stellar giant is highly unstable and prone to violent outbursts. In the 1840s, it briefly became the second brightest star in the night sky during what astronomers call the Great Eruption. The nebula itself is a masterpiece of colors and shapes, with dark dust lanes weaving through bright, glowing gas clouds. It's like a cosmic abstract painting that stretches across 70 times the size of our entire solar system. The Carina Nebula also hides a fascinating secret. It contains mysterious structures called Bok globules, which are dark clouds of dense cosmic dust and gas. These globules might look ominous, but they're actually cosmic cocoons where future stars are taking shape. Some astronomers believe these globules might also be the birthplaces of planetary systems similar to our own. What makes these nebulae so special isn't just their stunning appearance or vast size, it's how they connect us to the cosmic story. When we look at these nebulae, we're watching the processes that created the elements in our own bodies, the birth of new solar systems, and the endless cycle of stellar life and death that keeps our galaxy evolving. They're not just distant clouds, they're windows into our own cosmic origins. The mesmerizing beauty of nebulae has done far more than just advance our scientific understanding. It has deeply influenced our culture, art, and imagination in ways you might not expect. Let me take you on a journey through this fascinating intersection of science and creativity. Throughout history, these cosmic clouds have sparked human imagination in remarkable ways. Vincent van Gogh's famous painting The Starry Night, created in 1889, shows swirling patterns that bear an uncanny resemblance to actual nebula formations we've since discovered. Isn't it amazing how an artist's intuition could capture the essence of cosmic structures before we had the technology to see them clearly? In literature, nebulae have inspired countless science fiction writers to dream up extraordinary stories. Arthur C. Clarke, in his renowned Space Odyssey series, used nebulae as mysterious gateways to other dimensions. The famous author Terry Pratchett once described nebulae as the universe's art gallery, and he couldn't have been more right. Modern authors continue this tradition. In recent years, nebulae have appeared in everything from poetry collections to graphic novels, symbolizing both the beginning and end of existence. But perhaps the most fascinating cultural impact of nebulae comes from how they've influenced modern mythology. Take the Pleiades star cluster and its surrounding nebulosity. While ancient cultures saw it as seven sisters, modern storytellers have reimagined it in countless ways. Native American tribes saw it as seven children ascending to the heavens, while contemporary science fiction often portrays it as a gateway to advanced civilizations. The names we give to nebulae tell their own fascinating stories. The Butterfly Nebula, the Cat's Eye Nebula, the Horsehead Nebula. These names reflect our very human tendency to find familiar patterns in cosmic shapes. It's like a celestial Rorschach test, where each culture and generation sees something slightly different in these cosmic clouds. In modern popular culture, nebulae have become iconic symbols of space exploration and discovery. They've appeared on everything from album covers to fashion designs. Pink Floyd's The Dark Side of the Moon album artwork was partially inspired by nebula photographs, and numerous video games feature nebulae as breathtaking backdrops for space adventures. Even the fashion industry has embraced nebula-inspired designs, with galaxy print becoming a recurring trend in recent years. The role of nebulae in public science engagement cannot be overstated. When the Hubble Space Telescope first released its stunning images of the pillars of creation in 1995, it didn't just excite astronomers. It captured the public's imagination worldwide. These images have become so iconic that they've appeared on postage stamps, museum walls, and even cathedral windows. Social media has taken this fascination to new heights. Nebula photographs regularly go viral online, inspiring artists, photographers, and digital creators to produce their own interpretations. There are entire online communities dedicated to nebula art and astrophotography, sharing techniques for capturing and rendering these cosmic wonders. Perhaps most importantly, nebulae serve as a bridge between complex scientific concepts and public understanding. When people see these beautiful cosmic clouds, they naturally want to learn more about what they're looking at. This curiosity has led to increased public support for space exploration and scientific research. The impact of nebulae on our culture shows how science and art aren't separate realms, but rather two sides of the same coin. These cosmic clouds remind us that the universe isn't just a collection of physical laws and chemical reactions. It's also a source of beauty, wonder, and inspiration that continues to shape human creativity and imagination. In the end, nebulae teach us that the most profound scientific discoveries can also be works of art, inspiring generation after generation to look up at the stars and dream of what's possible. They remind us that in our quest to understand the universe, we're not just gathering data, we're also telling the greatest story ever known. The future of nebula research is nothing short of extraordinary, and I'm excited to share with you what lies ahead in this fascinating field. We're standing at the threshold of discoveries that our astronomical ancestors could only dream of. Let's start with the incredible new tools we're developing to study these cosmic clouds. The James Webb Space Telescope has already revolutionized our view of nebulae, but it's just the beginning. Coming soon is the giant Magellan Telescope, with a mirror spanning over 80 feet across. Imagine a telescope with the surface area of a tennis court. This behemoth will be able to capture images 10 times sharper than those from the Hubble Space Telescope. It's like upgrading from your grandfather's old binoculars to a super-powered space camera. But here's where it gets really exciting. The next generation of telescopes won't just take pretty pictures. They'll be able to analyze the chemical composition of nebulae in unprecedented detail. The extremely large telescope, currently under construction in Chile's Atacama Desert, will be able to detect the faintest molecular signatures in these cosmic clouds. Think about that for a moment. We'll be able to study the chemical recipes for planet formation as they're being mixed in these stellar kitchens. Speaking of chemistry, one of the most thrilling frontiers in nebula research is the hunt for complex organic molecules. We've already found simple organic compounds in nebulae, but scientists believe these cosmic clouds might harbor the precursors to life itself. Some researchers think that nebulae might be cosmic organic chemistry laboratories, creating the building blocks of life long before planets form. It's mind-boggling to think that the molecules necessary for life as we know it might be floating around in these beautiful space clouds. The European Space Agency is planning a mission called Ariel, which will study the atmospheres of exoplanets and their relationship with nearby nebulae. This mission could help us understand how planetary atmospheres form and evolve, potentially giving us clues about how our own Earth's atmosphere came to be. It's like having a time machine that lets us peek into the early days of our solar system. One of the most exciting aspects of future nebula research involves understanding how planetary systems form. We're developing new techniques to study protoplanetary disks within nebulae. These are the cosmic cradles where baby planets are born. The upcoming Plato mission will help us connect the dots between nebular material and the formation of rocky planets like Earth. Imagine being able to watch the birth of a solar system similar to our own. Advanced artificial intelligence and machine learning are also transforming how we study nebulae. These tools can analyze vast amounts of data and identify patterns that human observers might miss. They're helping us create detailed three-dimensional maps of nebulae, showing us their true structure in space. It's like finally being able to walk around and through these cosmic clouds. Here's something truly fascinating. Scientists are developing new ways to study the magnetic fields within nebulae. These invisible forces play a crucial role in star formation, but we're only beginning to understand their importance. Future telescopes will be able to map these magnetic fields in detail, showing us the invisible hands that help shape cosmic matter into stars and planets. We're also on the verge of understanding how nebulae interact with their surroundings on a galactic scale. New surveys will map the distribution of different types of nebulae throughout our galaxy, helping us understand how they influence galactic evolution. It's like creating a cosmic census of our galactic neighborhood. The future of nebula research isn't just about new discoveries, it's about understanding our own origins better. Every advance in this field brings us closer to answering fundamental questions about where we come from and how common planetary systems like ours might be in the universe. As we peer deeper into these cosmic clouds with our new tools and technologies, we're not just studying distant space phenomena, we're uncovering the story of our own cosmic heritage. The future of nebula research promises to be as beautiful and awe-inspiring as the nebulae themselves. As we reach the end of our cosmic journey through the world of nebulae, let's take a moment to reflect on what these magnificent celestial objects truly mean to us. They're far more than just beautiful space clouds. They're windows into the very processes that make our universe tick. Think about it. Every time we look at a nebula, we're witnessing the fundamental cycles of cosmic life and death. In these vast cosmic clouds, we see the same processes that created every atom in our bodies. The calcium in your bones, the iron in your blood, the carbon in your cells. All of these elements were forged in the hearts of ancient stars and scattered through space by the same kinds of nebulae we've explored today. Our connection to these cosmic phenomena runs deeper than many realize. We are, in the most literal sense, children of the nebulae. Every breath you take contains atoms that might once have been part of a brilliant nebula thousands of light years away. When you look up at the night sky, you're not just an observer. You're part of this grand cosmic dance that's been ongoing for billions of years. The beauty of nebulae continues to captivate us, just as it did our ancestors who gazed up at the same sky with wonder. From the delicate tendrils of the Veil Nebula to the towering pillars of creation, these cosmic formations remind us that the universe is not just a vast, empty void, but a canvas painted with light and color on an unimaginable scale. The mysteries of nebulae still beckon to us. Every new image we capture, every piece of data we collect, opens up new questions about our cosmic home. How many planetary systems are being born in these stellar nurseries right now? What undiscovered secrets lie hidden in their glowing gases? These questions drive us forward, pushing the boundaries of human knowledge and technology. As we wrap up our exploration today, I invite you to maintain that sense of wonder you felt while learning about these cosmic marvels. The next time you look up at the night sky, remember that you're not just looking at distant points of light, you're looking at the very processes that made your existence possible. And this brings me to an exciting invitation. If this journey through the nebulous wonders of space has sparked your curiosity, why not continue exploring with us? The universe is full of fascinating phenomena waiting to be discovered, and our channel, Exploring the Universe, is your gateway to these cosmic wonders. By subscribing to our channel, you'll join a community of fellow cosmic explorers as we venture through stellar nurseries, dance among supernovae, and unlock the secrets of our fascinating universe. Each week will bring you new adventures in space exploration, from the birth of stars to the death of galaxies, all explained in ways that bring the cosmos closer to home. hit that subscribe button and let's continue our cosmic journey together. Share this video with friends who gaze at the stars with wonder and help us build a community of space enthusiasts who understand that we are all truly connected to these magnificent cosmic clouds. Remember, every great discovery in astronomy started with someone looking up at the sky and asking questions. So what celestial mysteries will we explore together next? Join us on Exploring the Universe, and let's find out. Until our next cosmic adventure, keep looking up and wondering about the magnificent universe we call home.